Okay, today we are going to take notes on writing two-variable equations. And the objective is I can write a two-variable equation in order to solve real-world problems. To start off with, it's important that we understand some key vocabulary. First of all, an equation in two variables represents two quantities. So if you write in the word quantities, that change in relationship, write in the word relationship, to one another. An example is 3x equals y. Okay, or x minus 5 equals y. So let's further understand this. The solution in two variables is an ordered pair. That makes an equation true. Write in the word true. An ordered pair that makes an equation true. So, example, if you have the ordered pair x and y, and then 3x equals y. Okay, so always in an ordered pair, it goes x first and then y. We talked about this yesterday. And if you have this equation 3 times x equals y, and you're given the ordered pair of 2, 6, this is x, y. So instead of the x, you're going to put in the 2. And instead of the y, you're going to put in the 6. Okay? So in other words, 3 times 2 equals 6. Try the next one. If you're given the ordered pair of 3 and 9, this is your x, this is your y. 3 times x, or 3 times 3, equals, y is 9. 3 times 3 is 9. 9 equals 9. Okay, independent variable is the quantity that can change freely. The x in the ordered pair. Example. 3 times, whatever x is, it's going to change every time, right? 3 times 2, in this case it's 3 times 2, but if it was a different number it would change, and so it's the independent variable. Okay, the dependent variable is the value that depends on the value of the independent variable. This is going to make more sense when we practice these. The y in the ordered pair. So in other words, the y is depending on the x, and the x is the dependent variable. Okay? Let's turn our notes over, if you will. Here we go. The key idea, tables, graphs, and equations. You can use tables and graphs to represent equations in two variables. The table and the graph below represent the equation y equals x plus 2. Okay? So what happens if you're given an x value and you're given a y value, you plug them into the equation and graph them. So here you have x at 1 and y at 3. So I start at 1 and I go up 3. The ordered pair 2, 4. I start at 2 and go up 4 and I end up right here. Order pair 3, 5. I start at 3 and I go up 5 and I end up right here. And this graph represents y equals x plus 2. So what can we learn from this table and graph? What can we learn from the table and graph of the equation y equals x plus 2? As the x value increases by 1, the y value increases by 2. So no matter what the x value is, the y value will always be 2 more than the x value. Okay? So pause and try this part if you will. It says using the equation 2x, complete the table that shows the relationship between the independent variable x and the dependent variable y. So when the independent variable, or x, is 1, what is y? Okay, you've got the, once again, it's y equals 2x. So if the independent variable is 1, 2 times 1 equals what? What is the y? 2 times 2 equals what? What's the y? 3 times 2 equals what? Okay, what is happening? And then answer that question, what is happening to the independent variable each time? So pause and try that. And then turn it back on or unpause it. Okay, welcome back. So together, you go to Yogurtland to get a treat. The ice cream costs $4, and each additional topping is 25 cents each. Write an equation using two variables you would use to find the total cost of your ice cream. What is the independent variable that will change freely? What's going to change freely? It's your x, right? In this problem, what will your x represent? What's changing? Is it the cost of the ice cream, or is it the amount of toppings? Okay, it's the amount of toppings, right? The ice cream is going to cost $4 every single time, no matter what. The toppings, depending on how many you get, that's going to change all the time. Okay? So that's the one changing all the time, is the x, the independent. It's independent. It changes. What is your dependent variable that will change in relation to your independent variable? Y. What does the dependent variable represent? It's the ice cream, right? Actually, I just did that wrong. Okay, Mrs. Lloyd just goofed up and discovered that I did that wrong. Let's go over what does the dependent variable represent. Actually, go over all of these, okay? So the x represents the toppings. The $4 is the ice cream. It's your constant. It's staying the same. And the y is your dependent variable. And the reason why is because it depends on whatever x is, the number of toppings. This is always going to change. Based on whatever x is going to make y change. So this is your independent, the toppings. Because it's always changing. However many toppings you're going to get. The y depends on that independent variable, because depending on how many toppings you get, 3, 4, 5, 6, whatever, that's going to change your answer here, right? It depends, the solution, or y, depends on x, the independent variable. And the constant's of $4 ice cream is never going to change. And yes, teachers make mistakes too. I just showed you that. Now you're going to pause and try to get this last one on your own. When you're done, bring it to me and I'll check off both of the pause and tries, and you can take 2 tickets and go on to the assignment. Thank you so much.